Okay, so yesterday we did adding, but adding the step of finding a common denominator. So we needed to find a common denominator, change the numerators, and then subtract the numerators. Because remember, when we find that common denominator, we leave it alone. We did way too much work to find that thing to not use it, right? So we move that denominator across, use it, add the numerators together, boom, fractions added. Today we're doing subtracting, which is the same thing, but very, very, very slightly different. So which one do you guys want to try? Which one? Start with number 2? Cool. That is 3/4 minus 3/8. So you guys are going to find this pattern really familiar because it is going to be exactly identical. Literally the only thing we change is the operation. So finding the common denominators is the one that's all the work, but it's also not different. Like it's nothing you haven't done before. So when we look at the 4 and the 8, we can see our common denominators. But if we're going to use the visual method, I want us to list them anyway. We don't have to list a bunch of them. We're going to list them until we get one we know will work. 4, you can't multiply and turn 8 into a 4. But you can multiply and turn 4 into an 8, right? And an 8 is already an 8. So on this one, we're good to go. We don't need to change anything about that. We need to change this 3/4 into 8ths. So we put it in our fraction machine, right? 3/4 times something over something, a fraction equal to 1. You guys have heard me say this like 49,000 times now, right? Remember, if it helps, picture me, or say what I would say. Take our fraction, times something over something, equals a fraction, thought you might, has a denominator of 8. So when we set up this, your brain automatically can fill this in. It will bug you to know that this is gone. Sir, see, please. I'll get you in just a minute. So what goes in here? Just fill in the blank. Leo. 2. Now we fill in that blank. If our fraction is going to stay equal to 1, that means we cut this one thing into 2 pieces. How many pieces do we need to keep? 2. Which means now we know we multiplied across to get this. What do we do at the top? Multiply right across. That turns this little machine we build is an algorithm. Remember, algorithm's a machine we put the numbers through to make them work for us. This little machine we built turns finding a common denominator into quick mental math. The only hard part about the algorithm is it takes a lot of writing, right? So now we know we've got this 6/8 as an equivalent fraction to 3/4. We took the top times 2, we took the bottom times 2. Numerator times 2, denominator times 2. Can we subtract this now that we have similar pieces? Yeah, totally. And it really breaks down to definitely keep the common denominator because we did too much work to get rid of that, right? So we have 6/8 and we have 3/8, so we're subtracting 8ths.
6 minus 3.
So it's just 6 minus 3. What's 6 minus 3? Yeah? Everybody looks at me like, seriously? You're asking me that question? Yep, I'm the teacher around here. You guys get to do the answers, not me.
Can we do number 4 next? Because I want to do one that we have to change both, not just one.
Okay, yeah. Do you guys want to do one where we have to change both of them? Cool.
Because on number 3, you only have to change one.
I like it. So number 4 is 1/2 minus 1/5. Okay. Yesterday, when you guys were doing this, did anybody get to the point where you kind of felt like it was easy?
Mm-hmm.
Okay, you'll get there today too. Some of you guys are looking at this like, you'll get there today too. When you see the pattern of it, you'll go, oh, that's all?
I got it when I started doing the work that you gave me for the week.
I would think so, yeah. Okay, so our common denominator, 2, 4, 6, 8, 10. We pretty much knew that already, but we're going to do it anyway, just so we can have it in front of our faces. So our common denominator is going to be 10. Now we need to change both fractions.
That's what I wanted to do because I wanted to make sure.
Yeah, and it's just going to be the same little machine. We're just going to run 2 fractions through it instead of 1. So if we do our 1/2, say it for me. 1/2 times something over something, fraction equal to 1, equals a fraction with a denominator of 10. This is the blank we're talking about that gets us where we need to go. So we have a blank across the bottom. We have that variable. We don't know what this is, right? 2 times 5 equals 10, clearly, right? 5 in the denominator, 5 in the numerator. What do we do with the top? Multiply right across. Boom, 5. Go ahead and get ready. It's okay. We're taking a video, but it's no big deal. So now we change our 1/2 to 5/10. Now nobody on camera is going to be able to see that. Now we need to change our 1/5 to tenths, right? Times something over something, fraction equal to 1, equals a fraction with the denominator 10. Again, that's our blank we're talking about that gets our key. We already did this multiplication up here, up top, right? 2 times 5. If we got the 5, we can flip-flop the 2, right? And what do we do? Multiply straight across the top. What do we got?
I'm way behind right now.
Okay. All good. So we had this blank here. 5 times something equals 10, right?
Yeah.
We knew our something had to be 2. We flipped our 2 up the top.
So 2 tenths.
Yeah. And you see how quick that is? Boom. She goes, oh, I'm way behind. Oh, 3 seconds later, no, I'm cool. I got
And
this.
then would we just
Now.
add 5 and the 2?
Yeah. We're going to take our 1/2. No. Remember, we're not adding. We're subtracting.
Oh, yeah.
Our new equivalent fraction for 1/2 is 5/10. So we just replace it.
So
Our new equivalent fraction for 1/5 is what? What do we change 1/5 into? 2/10. So now we've got 5/10 minus 2/10. Yeah. No, don't say it hesitant. Don't say like, I don't know. No, you totally know this. Once you get it to this point, once you put it through our little machine here, you got this. Is all mental math, and it's literally kindergarten subtraction. It's literally like little bean counters. You've got 5. Miss Shonda says take away 2. You take away 2 from these left. Not any harder than that.
What I was wondering is if we would take those 2 and do something to it before we did that, or if we would take
Nope. These 2 parts right here, these are our goal. We needed these fractions to have a common denominator, so we messed with them until they had a common denominator. We just used that identity property of 1, chopped up our 1, changed it up. These fractions are equivalent, so they're the same fraction, just represented a little differently. It's that broken dinner plate, right? So it just broke our dinner plate into more pieces. Do you want to see the MobiMax way? Or no? Okay.
Kind of.
Then I'll do,
No.
if you want to see the MobiMax way, stay. If you want to see the MobiMax way, come up. But don't bang the camera around too much. If you want to see, the MobiMax way, come up, and we're still recording. So if you want to see the MobiMax way, come up. You're good, man. We're in the middle of recording, dude. Yes, you know those things to do. Okay, so the MobiMax way. Let's do 7/8 minus 1/2. Good thing about the MobiMax way, it's real fast. Bad thing about the MobiMax way, if you're visual and you like to see your pieces, it's going to be a little more confusing because it expects you to see the pieces in your head, not on your work. So if you're uncomfortable not seeing those pieces on your work, like I always was, I always wanted to see all my pieces because I'm a puzzle guy, I'm a problem guy, I can figure out how to solve stuff. Give me a blank, I can fill in the blank. Put the blank in my head, my whole head's blank.
Mm-hmm.
Yeah. So if that's you, and you look at this and go, just don't. Just quit. So to find a common denominator, not the lowest, but a common denominator, we multiply 8 and 2, right? That's 16. Now, we multiplied this 2 times 8 already, correct? So to get our equivalent fraction, what we need to do is multiply the numerator times 8 too. So what is 8 times 1?
8.
Yep. Now we have a new fraction that is equivalent to 1/2, but has a common denominator of 16ths. So we multiplied this 8 times our 2, so opposite denominator, to get 16, right?
Or is
It's scribbled out. We took this 2, we multiplied 8 to get 16, correct? Now we need to multiply our numerator times this 2 to get an equivalent fraction. So what is 7 times 2?
7 times 2, 14.
14. It's a shortcut. And if you're good with that shortcut, you can see it in your head, you understand how it works, you're cool with it, it's a great shortcut to take. If you're like me, math's a little bit more of a struggle, math's a little bit more visual, whatever it is, taking shortcuts is not always our friend, right? If you're the person who's not great at following directions in the car, you don't want that person trying to find a shortcut, right? Because they're probably gonna get lost anyway.
Or crash.
Yeah, or crash. Like we don't want to set ourselves up to crash or get lost or anything. So if you need to see the pieces, write out all the pieces. It only takes like 10 more seconds. So now that we've got our equivalent fractions, 14/16 minus 8/16. The Mobimax way just skip that times something over something. We did that by looking at the opposite denominator. What is, we've got 16ths. We know our answer is going to have a denominator of 16ths because we need to work too hard to waste that one. We're keeping it around. It's 14 minus 8. Boom. That's it. We do have people in 5th grade now who have done this enough times, they're starting to be able to do the whole thing in their head. And that's a very good thing. But it is a very risky strategy to do the whole thing in your head, because if you look at your work, you can tell if you did something wrong. Each one of you sitting at this group right now has come to me and be like, something's not right here. Yeah, I have never got to the point where I can automatically do this in my head. With like 2s and 4s, if I'm finding a common denominator that way, I can.
All of this, I can't do that in my head.
No, and if you're not comfortable with it, don't do it. If we've got a good tool that works, use the good tool that works. If you've got a tool you're less comfortable with, why would you use a jackhammer when you're more comfortable with using a hammer, right? If they both do the same job, one just requires a slight, like this much more effort. Feel good? All right, cool.